Nice to meet everybody. My name is Markus Feyh. I'm engineering manager at The RealReal. I've been using Airlang for about 8 years and then Elixir professionally off and on for about 2-3 years now. I'm going to give a talk about remote tracing and production clusters. And you might ask yourself, why is this important, or what's even the value to do remote tracing in production clusters? Well, there's multiple reasons. One is it's a great tool when you're trying to debug really hard to find problems that are like kind of needle in the haystack, one-off occurrences, maybe only occurring on production systems. It's also a great way if you need to collect real examples of data live on your production system where you're curious. Maybe it's even, this is maybe a stretch, but maybe you're even interested in collecting some data to run through your system to use for testing data. And then third of all, sometimes it's just a great check if there's something kind of deep in your stack and you're just wondering, hey, I wonder how that new functionality I actually implemented is being called, or if it's even being called at all, because you're wondering, like, did the code even deploy or something? It's a great way to do that as well. Now, what makes this different, because there's been many talks on tracing. What makes this talk different than other talks on tracing? Well, this talk specifically, I'm going to focus on tracing on production systems and give it from a very practical perspective. I'm going to give you a demo at the end, and I'm just going to break it down very simply to kind of give you a foundation so that when you want to jump into this, to do this, you'll have a good foundation, but also an ability to kind of reach out and learn more as you go along. So let's get started. All right, so we kind of started with the big title and we're going to break it down. So remote tracing, what is that? Well, remote is something that is not local to your machine is the best way to kind of, that I think about that. And so that might be like a server that's deployed, that might be another node on even on your own machine is remote to your local console. So remote is basically just not what's on what your console is natively connected to when it starts up. And then tracing is what you're actually going to do and what I'm going to show you how to do. Essentially, you're checking the state of the system. You're doing this because you have a desire to open up the system and see what is actually happening inside the system, what parameters are being passed, what function calls are being made, and so on. So that is remote tracing. It's not your local machine, local node, local console, and you have a desire to do some tracing to get an insight into the system state or how it's operating. All right, so what does that look like in practice? In Elixir, which is really interesting. So we start kind of with just an Elixir console on the left. You can see the IEX1, we just opened up our console. How does that work in practice? Well, it itself is a console, and then it's connected to a shell process, which is running on an Elixir node in a Beam VM on your machine. And that's just kind of like the initial state. So when we think about wanting to connect to another node, another Beam VM, over the network, on the same machine, so forth, what we're thinking about is how can we actually connect into the shell of another Elixir node somewhere else? And so Elixir is really interesting because it's built on the Beam VM and can transparently handle this. And so our console can actually, it'll look exactly the same, and we can set it up to remotely shell into another Elixir node on a remote computer, for example. This could be our production servers, could be our testing servers, or so on. And so what happens when you're connected into that remote computer, you're actually connected in your consoles is connected to that shell of the Elixir node of the remote computer. And why is that all transparent? Well, that's one of the amazing things about the Beam VM. It's all message passing. So whether it's message passing to your local node or message passing to a remote node, it's all transparent to you. All right, so we established a little bit about what the remote part of remote tracing is, and now I want to cover what are the typical things that you will trace. And this is kind of in order of a lot of the most common things. So I would say the most common thing is people are wanting to trace function calls. So what are the parameters being passed in? What are the return values? Why is a function being called? And the tracing that you're going to get is a text-based interface. So you're going to see, and I'll demo this at the end, but you'll see the actual function call, what parameters were passed in, maybe what the return value was, what the stack trace was. So you have functions you can trace, you have processes you can trace, you have ports you can trace, and messages that are passed between processes. You can even trace some of these in combination. So when you're thinking of a larger system, you may only want to trace the function calls of a specific registered process, or maybe just the messages or function calls of a specific child process of a supervisor in your system without getting the tracing for everything or every similar process in your system that's making those function calls. So it really provides a lot of flexibility to slice and dice your system and almost do surgery on it in multiple ways to get an insight into the state of it. So what does that look like in the Beam VM? Well, underlying all of this tracing is this built-in function called Airlang Trace. And this is just a very simple example. Where it says Airlang Trace everything true, and then all the function calls. And this will basically trace all the function calls on that node that you just ran that on. And that is very dangerous to run on a production system, but I just want to give you an idea of what's underlying all of this. So the syntax and the function calls for this kind of comes from this root of the Airlang Trace. Built on top of that is DBG, which is another module built into Airlang, into the core library. And this is an example of tracing a specific process ID. So what DBG adds another layer on top of Airlang Trace, and it really brings in the ability to do more targeted tracing on remote machines, on specific processes, and that's something that you're not going to get just by using Airlang Trace necessarily, especially with the remote tracing. So this is sort of like we're building up layers. So we kind of covered Airlang Trace, which is kind of the lowest level, and then DBG. But the thing is, I wouldn't recommend, and I would never use either of these on a production system because they're very complex. It's very easy to make mistakes. And on top of it, there are great libraries out there that are much more friendly and safer to use on your production systems. So I don't recommend using Airlang Trace natively, and I don't recommend using DBG locally or when you're remote tracing either. So I recommend using these libraries, and there could be more, but these are just sort of the top three that I looked at so far. And what I'll show you specifically in this talk is Rexbug, which is built on Redbug from the Airlang ecosystem. It's my go-to, but there's also Tracer, which I kind of looked through. It looks like a very nice attempt, so I'll give an honorable mention to make a more Elixir-friendly tracing tool. And there's Tap, which is based on Recon. I believe there's another talk on Recon tracing in ElixirConf, so you might want to rewind and rewatch that one if you're interested. That's also a great tool. It comes out of Erlang and Anger is a great operator's manual for that, which is really a guide on how to kind of debug your Beam VM when it's not behaving as you expect. And so that's called Tap, and that's also a great option I recommend. So that's an Elixir library that kind of wraps the Recon, the Erlang library. So a lot of these tools really come out of the Erlang ecosystem, and which makes sense because the tracing is really something that is so native to the Erlang ecosystem. And so by the time I think Elixir came around, it's just easier to kind of build on top of that great tooling and add the Elixir syntax. All right, so we've kind of gone through remote tracing. We kind of understand it theoretically. We understand some practicalities around it. And next, we want to talk about, well, what makes this special when you're dealing with a production cluster? Your production cluster or hosts or however you host your production code might be hosted on AWS. It might be Heroku. Elixir looks really interesting as well. And there's a number of other great places where you can host your Elixir code. You might be running in a clustered way where all your nodes are connected with each other, or you might be running in kind of a stateless way where your nodes aren't all connected with each other. Kind of a side note here, there are really cool things as your clusters grow that you can do with tracing, where you can kind of layer AppleScript on top and open up 20 consoles and so on. So I just lost the camera. Let me see. Apologize. See if it comes back. All right, we're back in action. And so there's a lot of cool things, but this is a side note. If you're interested in that, feel free to reach out. I'll leave my email as well at the end of this talk. All right, so we're going to jump into what makes the production cluster tracing different. So at a high level, going back to our diagram at the beginning, we have our computer and we have that production cluster, that remote node. And this is what makes it much more exciting, because in between probably your computer and your production system is probably some security layer. So that could be like a VPN, maybe IAM roles in AWS, some kind of single sign-on maybe for your company, or a jump box that you need a proxy through, or maybe some kind of SSH key authentication where you need to put your public SSH key on the machine so you can SSH into it. So there's usually something there, and it can be so different. So I'm just going to give you an overview of, like, there's probably some mechanism there that you're going to have to be aware of to get onto that machine in the first place. So in practice, kind of for Heroku, just some of the common cases that I see is that Heroku, AWS, and Elixir are the ones that I'll cover, but there's probably lots of other ones, and I think they're great to document. And but I just want to focus on these in the consciousness of time. So first with Heroku, the way to open up a shell, Heroku ps:/exec, and then the key here is with --dyno. You want to actually specify the specific dyno. So let's say you have 10 dynos on Heroku. You're doing a rolling release. Maybe as it's shutting down and spinning them up, some of them are getting restarted or some of them are not even started. So you kind of have to know which one you want to jump into. And you may also know which one you want to jump into, because maybe one is behaving in a way that you want to get insight into. So maybe you want to look into web.5 because you're seeing some concerning logs there or something like that. So that's how you do it with Heroku, just to get on the box and to get past security. And in order to do this, you need to have set up your Heroku CLI tools and authenticate yourself with Heroku ahead of time. All right, so that covers Heroku. AWS, a little bit different. You want to set up your PEM key ahead of time. And this is like creating a shared credential. The next kind of challenge usually with AWS is the instance naming isn't always like as fixed or simple. And so there's different strategies that I've heard of in industry. Some people will tag their production servers or staging servers or testing servers or so on. So they kind of can just quickly kind of query, oh, I have all of these servers, for example. I'm interested to hop into these ones. And I can just dynamically check what the latest host names are. So that's a great way to kind of overcome that complexity. But then in essence, what you're doing is you're just doing SSH. You're passing in your shared credential, and then you're saying the host name that you want to SSH into. Then finally, Elixir, give this an honorable mention. I just ran into this kind of as I was researching this. I think their documentation is amazing, and their support for Elixir. I thought they made it really easy. They have some other kind of cool commands around Observer and other things that you can really benefit from. And their command is just as simple. After you set up gig Elixir with your SSH key and so on, you can just run gig Elixir ps:/remote_console, and that'll open up your batch console on the machine as well. All right, so we're on the box. We've accessed production. We've kind of overcome that security hurdle to get onto the servers. So the next step is attaching to the actual Elixir console, because we want to be able to interact in an Elixir way with our deployed server. So we'll just walk through this line by line. IEX, that opens up a console. Another parameter, command line parameter we pass in is a node name. We need to pick a name for our node that we're gonna connect from into that node. So in this case, I just provide an example where you can generate a UUID gen. This is a common kind of CLI command that you find on a lot of CLIs. If not, you can just put like Bob or your name. If someone's interested in who's kind of connected to the console, then they can kind of trace it back to you. Next line is a cookie. So the most common way that Elixir and Airlang kind of validate secure communication is by validating that all the nodes that connect with each other share a secret cookie. And so in this case, you'll want to specify a cookie. So it has to be the same cookie as the node that you're connecting into. So if it was, I don't know, this is a really terrible example, this is not secure at all, you'd want to use something much more secure. But in this case, maybe the node there was deployed with the secret cookie, and so we have to use cookie as well. And the next thing is you can pass in another command line parameter and say remote shell. And then node is just an example. Your node might be called something else, might be called server, might be called node, might be called like user service or whatever you decided to kind of name your node. And then it's at, and then this kind of $ hostname will just insert the hostname, which is usually pretty common, where it just, the node adopts the full name of the node name plus the host name. And so that'll then immediately, when you open up your shell, it'll already kind of take care of that step of connecting you into that shell process on the remote computer or the remote node. All right, so finally we got into the machines. We are now connected into the remote machine, and we're getting closer. But some things to be aware of. In order to make this all possible, you could try to trace and debug with some of those like low-level commands that I showed earlier in the presentation. But I highly recommend having some kind of library added into your node ahead of time. So all it takes is just adding a dependency. For example, for Rexbug, you just would have to add this to your deps in your mix.ecs file. So in this case, it's already included. So when I hop on the node, I can already start using that functionality because it's loaded into that node. I don't personally have to bring it in with me onto the server because it's already loaded onto that node that I'm going to be tracing on, so that makes it super easy. The other thing, again, is the secret token. So in this case, I just wrote secret in a little bit leet speak, but you probably want to have something very randomly generated and securely stored, which you can use to have as your shared cookie when you connect into the node. All right, so those are kind of preconditions. We're on the machine, and then we've connected into the console, and we're ready to start tracing our module. And this can be a very generic, very simple example. We're going to call this module name, which is a very exciting name, and it has two functions. The first function has two parameters, A and B, and what it does is it adds them together. And the second function has three parameters, and it will multiply them together. So a little bit different behavior. The interesting thing in this case is that that we do have the same function name, but with different amounts of parameters. All right, so what are we going to do? And I'm just going to kind of give a high-level overview of the demo, and then we're going to jump to the demo, and you're going to see this in practice. So at a high level, let's say we just want to trace all of function calls of module name of our module. And in this case, how that works in practice is the first parameter of Rexbug here. This means trace for 10,000 milliseconds. And then this means trace up to 10 events. And it's sort of like whatever whatever limit we reach first is when the tracing ends. And this is very important because tracing is something that adds load to your system. So you don't want to give it like unlimited time that it would trace or unlimited events that it would trace, because otherwise it'll just eat up a lot of IO, kind of spitting out the text of everything that's being traced. So in this case, this is sort of maybe a more reasonable. Maybe you're only interested, if it's a really high throughput system, you're only interested in tracing for like up to 10 milliseconds for one event, because you're just interested in sampling it very quickly. So just some context there. But in this case, just for the purpose of the demo, I need enough time to type, so we'll do 10 seconds. All right, so now let's say we only want to trace a specific function. So we can do module name dot function, and then with any number of parameters. In this case, it'll just trace that, and it doesn't care if it calls the function with 2 parameters or 3 parameters. This is kind of nice sometimes, especially for a lot of those recursive functions where you'll call in and then it'll call into another function with more parameters and kind of loop there and then come back. Sometimes it's nice to get the whole picture, and this is kind of easy way just to focus on that without having to specify every function specifically. All right, but let's say we want to know even more. We want to know what did the function actually return. That's really important. Like maybe we want to know, like, is this the function call that actually returned an error or something like that? And we want to get insight in this. So this next line is saying, hey, trace all function calls of module name with the function, and then give me the return value and also the stack trace. Stack trace might be interesting because we want to know what's calling it. Like, is this being called from this service or that service? And what's the path in which this was executed? And finally, let's say we were only interested in the initial call of something. Maybe there's something with multiple parameters, but we're only interested in the call that has 2 parameters. So in this case, and we're interested in the one with 2 parameters. So this could be underscore underscore, which would mean give me everything. This is sort of a special case because this is saying I'm only interested in the function parameters where the first parameter equals 1. You can add binaries, strings, atoms. So there's a lot of cool things you can do with this. I'll give an example. Let's say you're interested in a certain user and you want to check only when that username calls the function. You could specify that username in your tracing call and then say only when Markus at the real calls this function, I actually want to get the tracing for that, and the rest I just want to ignore because there could be like millions of other people calling that function. All right, so let's jump in to the demo. I'm going to drag a terminal over. Let's see. Make this a little bit bigger. I'm going to show you our function working. We're going to do 2 and 3, and we'll get 5 back there, and then we'll get 24 back there when we're multiplying them together. Okay, so we're ready to trace. I have some history here. So we're going to start with everything. So let's see, module name. Oh, interesting. We called the info there. It caught that. Okay, there, boom. So a lot of things to unpack here. First of all, it calls, when we trace the module, it traces everything of the module. So anything that could be called, including the underscore info. The other thing is it'll tell you the process ID, it'll tell you the timestamp, and then it'll tell you also the parameters in which it was called with. Here, you can see the 1, 2. It didn't give us the return value, it didn't give us a stack trace. We may be interested in that. So let's continue on and go through some other examples. So let's trace a specific one now. Let's see. All right, let's go for the return and stack trace of a specific function. We'll try that again. All right, so this time, now we can see a couple more things. We get both the stack trace here, and we also get the return value. By the way, this red bug done timeout means that we ended because we timed out. We hit our 10 seconds. All right, and then just one more example, a little bit, another case. Let's see. May not have that. Here we go. So this is the case where we want to trace a specific function called only when the first parameter is a certain number. So in this case, it will trace that, but if I change this to this, it won't trace it. And then you're going to see it time out here in a moment. All right. So that's a great way to kind of ignore certain tracing and then actually pay attention to other tracing. And that concludes the demo portion. I'm going to switch back here and then open the floor to any questions. I think honorable mention also here, the RealReal is hiring at all levels for engineering. So feel free to reach out. My email's here. If you have any clarifying questions, you want to just contact me directly, feel free to also contact me at this email.